Hi everyone. So let's continue with the 7th subtopic for this chapter. If you still remember, I've mentioned before that besides ray tracing, you can also use the lens equation to find the image of the object. So this is actually called the thin lens equation, where the equation or the formula is expressed as 1 over f is equivalent to 1 over u plus 1 over v. So f is you might be quite familiar with f now, which is the focal length. U would be the object distance, where the object position is, the distance of the object, and v will be the distance of the image. But from where? So the distance of the object will be from the center of the lens towards the object. So this will be the u. Whereas the distance of the image will be from the center of the lens to the image. So this will be your v. And of course your focal length will be the distance of your focal point, which will be from the center to the focal point. So this will be your f. Or there is another way to calculate, or there is another equation that you can use, which is 1 over f is equivalent to 1 over do plus 1 over di. So what will be the difference? Do will be the distance of object. Di will be the distance of image. The only difference between these two equations is the symbol. You can use uv, or you can also use do and di, whichever is easier for you. Another important equation will be the magnification, which is hi over ho. Hi will be your height of image divided by the height of object. If you don't have the height of image and object, you can also use the v and u. Again, I'll remind you, v will be the distance of image and u will be the distance of object from the center of the lens. For magnification, v over u, always remember to put the negative. I'll explain later on more on magnification. Let's try and do an example first. An object is placed at 10 cm from a convex lens. So the keyword that you need to know, what type of lens this is. So since it's a convex lens, the focal length must be positive. So this is f is equals to positive 15 cm. The object is placed 10 cm from the lens, meaning this will be your distance of object, or u. Determine the position and nature of the image formed. So position meaning they want you to find the v. Nature will be the characteristics of the image. So how do I do this? I can use the lens equation, which is 1 over f is equals to 1 over u plus 1 over v. So put in all the values. 1 over f will be the focal length, which is positive 15. And then is equivalent to 1 over u. Your u just now is 10 cm. Find your v. And you will get negative 30 cm. But this is not the end yet. You've only gotten the v. How about the nature? From the v, since this is negative, we know that the image is virtual, or at the front of the lens. That's only one characteristic. So how do I know whether it's bigger or smaller, upright or inverted? That will be determined by the magnification. So put in all the values. V is 30, negative 30, which is what you've gotten just now, and then divide by 10, and you will get negative, negative, so that will give you a positive 3 times. 3 times means it is more than 1, therefore the image is bigger. The positive negative sign, if you still remember, I've mentioned before, indicates whether the image is inverted or upright. So positive is for upright, whereas negative magnification means that the image is inverted. Positive magnification, the image is upright. So all the characteristics are there already. It's virtual, upright, and bigger. So I'll leave this for you to do. The answers are there already. You can double check them. And here are more examples that you can refer to. Please go through them for you to understand more on that. I'll go further into lenses. If let's say I have more than one lens, if the light passes through more than one lens, or we call this combination of two lenses, what would happen to the image? Which one would be the image? So how do you use the calculation? I'll explain this one by one, so listen carefully. Let's say I have my first lens here, and this will be the second lens, and the object is placed here. This will be the object. Do not look at the second lens yet. Just look at the first lens only. Okay, we'll focus on the first lens. So the first thing you need to do is solve the first lens equation. So let's say this is my u, which is the distance of object from the lens. How do I find my image? I will need to use 1 over f is equals to 1 over u plus 1 over v. So let's say I have my v value already, and the image produced is here. So this would be my v1, u1, and v1. So done with the first one. After that, what do I do? This image from the first lens just now will now become the object for the second lens. Now do not look at the first one. Only focus on the second lens. So I'm focusing on the second lens. Since this is my object, this will be my u. So again, I'm going to use the lens equation 1 over f is equals to 1 over u plus 1 over v to find the second image position. So this will be the final image position. So if they want you to find the final image position or the distance of the final image, you need to find v2. So, but how do I calculate the magnification then? For magnification, you have to calculate one by one. So calculate the magnification for the first lens, which is m1 is equals to negative v1 over u1. Once you've gotten this, calculate the magnification for the second lens, negative v2 over u2. Then you times both magnification for you to get the total magnification. Okay? Now it's hard for you to understand just by explaining, so let's do an example here. The second convex lens with a focal length of 15 cm, second meaning this is the first one, this is the second one, is placed 40 cm to the right of the first convex lens. So to the right of the first convex lens, meaning this is the second lens. with a focal length of 10 centimeters. So the focal lengths are given there. Since both are convex, both f is positive. An object is placed 60 centimeters to the left of the first convex lens. So to the left, 60 centimeters, this will be the object. Determine the location of the final image. So you need to find V2. Location meaning they only want V2. Does not mention that they want the magnification or the characteristic, so just find V2. So again, like I mentioned before, ignore the second lens. Let's focus on the first lens. 1 over f1 is equals to 1 over u1 plus 1 over v2. Sorry, v1. So put in all the values. I have my f there. I also have my u. I need to find my v1. So v1 here I will get 1 over 10 minus 1 over 60. 1 divided by answer. Don't forget to divide by 1. You will get 12 centimeter. So it should be somewhere around here. This will be your image. Now this is just an estimation of the image, but you know the position already. So from here, I need to calculate the image of the second lens. Now I can ignore the first lens. This image just now, V1, will become my object. So since this is the object, this will be my U2. So U2 will be 40 centimeter minus 12 centimeter. And that will give me 28 centimeter. Then only I can calculate my V2. U2 plus 1 over V2. So F2 given 15. U2 just now is 28. I can find my V2. So I will get here 1 over 15 minus 1 over 28. Now 1 divided by answer, we will get 32.3 centimeter. So let's check the answer. That's correct. So can you try and do this yourself? If you need to check the answer, you can refer to me. Or if you have any question regarding that, just come to me, okay?